Hello everyone, in this video we're going to be talking about regression in Stata. Now, the data sets available in the system use might vary according to your version of Stata, but out of the ones in mine, I'm going to work with this data set. And let's see here. So we have variables. Now, a good idea in general before you even begin any sort of regression analysis is just to get a little bit of a feel for the type of variables you have and what your research question was originally. So in this example, I am interested in looking at what sort of things determine one's wage. Years of schooling is one of the biggest sort of research questions in economics. What's the returns to schooling? So a simple example for that would just be a regression that's like, okay, you know what? If wage is my y variable and my input variable, beta 0 plus beta 1x, where x is just years of schooling, education or something, that's sort of like the simplest regression we can run if we're interested in finding the returns to schooling. So to do this, I would just need to type in the command reg yx, right? So reg wage education, whatever that variable is called. Let's see what the education variable is called. Well, just looking through here. Well, grade, the most current grade completed, is essentially what we want, years of schooling. We could even just get a sense of it. We could just do tab grade, tab or codebook, or so here, looking at the grade, the grade completed is essentially, you have people who've gone to grad school versus, high school. Yeah, notice 943 people have exactly 12 years of schooling. All right, so this makes sense. So let's just start with that very basic regression. So reg, wage, and grade. Okay, so this gives us, so once you type that in, that regression in, here's how you read this output. This stuff in the beginning is not really that useful for most purposes. The useful thing here in this top right, so again, there's essentially three sort of sections here. This top left, which is just some more advanced theoretical stuff. This stuff here, where the most important thing of this is this, the R squared, or the adjusted R squared. And so this is essentially, the way to interpret this is that 10.55% of variation in my, wage is explained by years of schooling, right? Adjusted R squared versus regular R squared, the slight difference there is just about whether you're penalizing yourself for adding more variables, but more on that later. For now, doesn't really matter. But yeah, so there's that. But then here in this bottom section, the main thing that we're after is the coefficients. And so the coefficient on grade, meaning years of schooling, is 0.74. So what that means is that for every extra year of schooling, my wage goes up by 74 cents. And this is notice hourly wage. So that means I make 74 more cents per dollar, per hour for every extra year of schooling. Now, if we want to check and see whether that number is significant or not, whether that it's even zero or not, we can just look further on that row. So the row for grade, for years of schooling, pretty big t-value, and so the p is definitely below our threshold, our alpha, which means that we're pretty confident that this number is not zero. Alternatively, we could just look at the confidence interval and see that 0 is not in it. So the plausible values for the actual slope here, meaning how much each year of school affects my wage, is anywhere from 65 cents to a high of 83 cents. So notice in either case, we're pretty confident that it's well above 0. It's not like there's no relationship. Okay. Now the problem here, you might think, if you were to just give this and say, all right, this is evidence that I think, years of schooling, every extra year of school makes your wage goes up by 74 cents. Well, several things. One is you're not really controlling for a bunch of other things that might be simultaneously changing. Like, what about the age? What if people with, a master's degree are just older or have more work experience or something, and that it's really their age or years of experience that's causing the higher salary, not the fact that they have a grad degree versus a bachelor's. And so, or versus a high school diploma even. So essentially what we're calling for here is we want to include more variables, and so our equation shouldn't just be this, but rather should also have like a beta 2 with, let's just say, years of experience, EXP, years of experience. All right, so the years of experience, there's total work experience, so we could include that. So let's go back to our equation, reg wage grade, and then we're also going to double click this for years of total work experience, and let's see what happens. Okay, we'll now notice our coefficient on grade went down a little bit, which sort of was expected. That means every extra year of schooling is not quite making it go up by 74 cents, but really only making it go up by 64 cents, because part of why it went up was also because you have more experience. But this is telling us something else, which is that every extra year of work experience is giving you 26 more cents per hour. And notice that our overall R squared is higher now, right? Our R squareds are around 14, 15% rather than just, 10, 11%. All right, so that's good. We're explaining more variation in wage. We're better predicting someone's wage because now we have not just, their years of education, but also their work experience. Notice here also that the years of experience has a p-value below 0.05 or 0.01, whatever you're using. And so the point is that both of these are significant. And so in general, if you have a variable that's not significant, where the p-value is high, above 0.05, your best bet then is to just drop that variable and to not include it because it's not really contributing to your regression. So, all right, so we have this. This looks good. One other thing we could do besides just adding more covariates, which, we certainly can. We can add, for example, whether somebody's married or not. So we could just add marriage. We could even add whether somebody is a college grad. And we can add whether somebody's in a union. All right, let's see what this does. Well, now notice, so all that's doing even more explaining, and so now each year of schooling only really gives you a 50-cent raise, is what we're coming to realize when you hold constant for all these other things. And notice here, turns out that, yeah, that 0.26 was kind of robust to adding these other things. So even if we added these other things, years of experience still added about 26 cents per hour. Marriage, the fact that it's negative means that if you're married, then on average you're earning less per hour than if you're not married. However, if you look at the p-value, this is pretty big, which means, again, or alternatively, if that's confusing, you could look at the confidence interval and you could say, all right, well, the true coefficient for marriage is either at, anywhere from 55 cents less per hour or 11 cents more per hour. So this means that 0 is in this interval, which means that we can't even rule out 0. So again, like I was saying, anytime your p-value is above 0.05, your best bet is to say, you know what, it's not that marriage is lowering your salary, it's just that it's not affecting it at all. And so our best bet is to run this regression without the insignificant variable. All right, so now we just have significant variables. Notice here that being a college grad, all else equal, gives you 74 more cents per 75 almost more cents per hour, and this is separate from just every extra year of schooling. And so this is also additionally saying that union, if you're in a union, you basically are getting $1 more per hour by being in a union, holding everything else constant. All right, so the other thing you could do, what if you were only interested in looking at a certain race of people? What if you were, debating, thinking about the effect of grade, schooling on this just for whites or just for blacks, for example? Well, in general, you could essentially restrict your sample to just a subset by doing this. So first, let's just look at how this race variable is coded. Let's do codebook race. All right, so there's white, black, and other. So so black is labeled 2. So if race has a value of 2, that means the individual is black. So let's do this. Let's look at our previous regression, but just say, so in general, when you type a regression, at the end of your reg y and then all your x's, if you type in if, and then you could restrict the sample. So we could say if race equals 2. So that's how you put a regression or restriction. You put the variable and then a double equals sign, or this could also be like a less than or greater than or something, and then the value that you want to restrict it to. So here, this regression will basically give us that same regression, but only for blacks. And so for blacks, every extra year of schooling, you could see what this slope is, and you could see what all these other variables are. So notice, being in a union, if you're black, being in a union makes your wage go up by $2 an hour, versus now, if we were to do this if you're white, the same thing, but race equals 1. So if you're white, being in a union only makes your wage go up by 60 cents per hour. Right? So that's sort of something interesting to notice, that the treatment effects, as we call them, are heterogeneous, meaning they're different for different subgroups of people. So this in general, so not only this, you could restrict this multiple ways. You could just say, just for a certain race and for, married couples or something, right? So you could even say if race equals 1 and if married equals 1 or something. And so this is further restricting your sample, So this and symbol is just adding to the restriction. So, and like I was sort of hinting at earlier, the restriction doesn't necessarily have to be something that's equal, but you could even just say, how does schooling affect wage just for low wage earners? So let's just first get a sense of what wage is. So sum wage, summarize the wage. So the average is about 7. The maximum is 40 bucks an hour. Minimum is $1 per hour. So let's do our regression again, but let's this time just say if wage itself is like less than 15. So if wage is less, so this is now going to run our regression, but only subsetting our sample to just people who make less than 15. So for those who make less than 15, every year of schooling gets you 42 more cents. Being a college grad essentially has no effect. You can see the p-value is pretty high. So what this means is if you make less than 15 bucks an hour, having a college degree does not change your wage. Versus if we were to do this for wage greater than 15, we could even do greater than or equal to 15. Well, turns out here, being a college grad, it's also, it's actually lowering your wage, and that's not significant either. But again, it's not significant, which really means it's a zero effect.